Hi everyone, I am Geeta, working as Assistant Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchengodu. Today we have to discuss about the topic multiple integrals. Introduction. A function f of x is integrated with respect to x limit between the limit as a and b. We get the definite integral as integral a to b f of x dx. That means the function f of x is integrated with respect to x. X limit varies from a to b. Lower limit is a and then the upper limit is b. If its integral is a function f of x comma y and if it is integrated with respect to x and y repeatedly between the limits x0 and x1 for x and between the limits y0 and y1 for y. We get double integrals, integral y0 to y1, integral x0 to x1, f of x comma y dx dy. In this integration, we have to repeatedly integrate two times. The first integrating with respect to x limit varies from x0 to x1. And then integrating with respect to y limit varies from y0 to y1. Extending the concept of double integration one step further, we get the triple integration, integral z0 to z1, integral y0 to y1, integral x0 to x1, f of x comma y comma z dx dy dz. In this triple integration, first integrating with respect to x limit varies from x0 to x1. Next integrating with respect to y limit varies from y0 to y1. Next integrating with respect to z limit varies from z0 to z1. For an example problem, evaluate integral 1 to 2, integral 3 to 4, xy, dy, dx. In this problem, first integrating with respect to y limit varies from 3 to 4. After that integrating with respect to x limit varies from 1 to 2. First integrating with respect to y means y is considered as variable, s is assumed to be constant. So integral 1 to 2, here x is constant, take outside, integration of y, we get y squared by 2. Limit varies from 3 to 4. Substituting the upper limit minus the lower limit. Here 1 by 2 is constant, take outside. Upper limit is substituting, we get 4 squared is 16 minus lower limit is 3 squared is 9. 16 minus 9 we get 7, 7 by 2 x dx. Here 7 by 2 is constant, take outside. Next integrating with respect to x. Integration of x is nothing but x squared by 2. Limit varies from 1 to 2. Substituting the upper limit minus the lower limit. Here 1 by 2 is constant, take outside, so we get 7 by 4. The upper limit is 2, 2 squared is 4 minus lower limit is 1, 1 squared is 1. 4 minus 1 we get 3, 3 sevens are 21 by 4. This is a solution for this evaluation, this integral. The next topic is change of order of integration in double integral. If the limits of integration in a double integral are constant, then the order of integration can be changed, provided the relevant limits are taken for the concerned variable. But when the limits for inner integration are functions of a variable, the change in the order of integration will result in change in the limits of integration. That is the double integral, integral c to d, integral g1 of y to g2 of y, f of x comma y dx dy will taken the form integral a to b, integral h1 of x to h2 of x, f of x comma y dy dx. That means dx dy is changed to dy dx. When the order of integration is changed, this process of converting a given double integration into its equivalent double integral by changing the order of integration is often called change of order of integration. To effect the change of order of integration, the region of integration is indefinite first. A rough sketch of a region is drawn and then the new limits are fixed. For an example problem, change the order of integration and hence evaluate integral 0 to 4a, integral x squared by 4a to 2 root ax, x by dy dx. First here, in the given integration, first integrating with respect to y, after that integrating with respect to x. Y limit varies from x squared by 4a to 2 root ax and then x limit varies from 0 to 4a. y equal to x squared by 4a means 4a is converting opposite side, we get x squared equal to 4ay. X squared equal to 4ay is nothing but upward parabola. And y equal to 2 root ax, squaring on both sides, we get y squared equal to 4ax. Y squared equal to 4ax is nothing but rightward parabola. And then x limit varies from x equal to 0 to x equal to 4a. The four limits can be shown in the following figure. Here x squared equal to 4ay is nothing but upward parabola. And y squared equal to 4ax is nothing but rightward parabola. And then x equal to 0 is nothing but y-axis. And x equal to 4a is nothing but vertical line, x equal to 4a. This point of intersection is nothing but 4a, 4a. First we have to find which is the common region of these four limits. X equal to, the four limits are x equal to 0 and x equal to 4a. So in this two line, inside the two lines, we get the general area. And then y squared equal to 4ax, x squared equal to 4ay. Intersection of this two one. So we get the common area as, required area as this part. Here the path are on vertical path. So in the required area, we have to find the strip. Strip is also vertical strip. Change the order of integration is nothing but the vertical path is converted to horizontal path and the vertical strip is converted to horizontal strip. In this next diagram, the vertical path x0, x equal to 0 to x equal to 4a is converted to y equal to 0 as the lower limit and then y equal to 4a. This point of intersection is 4a, 4a. So y equal to 4a. The vertical path is converted to horizontal path. And then the vertical strip is converted to horizontal strip. The strip is starting from y squared equal to 4ax to end as x squared equal to 4ay. So we get the new integration limit as changing the order of integration is nothing but to change the vertical path into horizontal path and to change the vertical strip into horizontal strip. We get the limit as x limit varies from x limit varies from here y squared equal to 4ax to x squared equal to 4ay. Y squared equal to 4ax, we get x value is x equal to y squared by 4a. Taking square root on both sides, x equal to 2 root ay. This is x limit varies from. And y limit varies from y equal to 0 to y equal to 4a. This is the new limits. Substituting in the integration, the given integral is integral 0 to 4a, integral x squared by 4a to 2 root ax, xy, dy, dx. dy dx is converted to dx dy. In the new limit, x limit varies from y squared equal to 4, y squared divided by 4a to 2 root ay. And y limit varies from 0 to 4a. This is changing the order. And then evaluate this integration. First integrating with respect to x. So y is keeping as constant. X integrating, we get x squared by 2. Limit varies from y squared by 4a to 2 root ax. Substituting the upper limit minus the lower limit. Upper limit is 2 root ay. 2 root ay whole square, we get 4ay. Minus lower limit is y squared by 4a, substituting, we get y power 4 by 32a square. Next, this y is multiple inside the bracket, we get this 2 should be cancelled, 2a y squared minus y power 5 by 32a squared. Next, integrating with respect to y limit varies from 0 to 4a. First, here the two terms are there. Two terms are in subtraction, so integrating separately. In this first term, 2a is constant, take outside. Y squared integrating, we get y cubed by 3. Minus, here 1 by 32a squared is constant, take outside. Y power 5 integrating, we get y power 6 by 6. 632s are 192. Substituting the upper limit minus, next step, substituting the upper limit minus the lower limit. The upper limit is 4a whole cube by 3 minus 4a whole power 6 by this term. Minus lower limit as 0. Simplify this, we get 64 by 3 a power 4. Thank you.